centimeter.
Yeah. So let's first draw the rhombus, okay?
All right.
How do you draw a rhombus? What did I tell you about a rhombus, Hiba?
It has 6 sides.
It has
6 sides.
6 sides. That is a hexagon.
Or a rhombus. Rhombus, I think it measures 90 degree.
No. A rhombus, in a rhombus, all the sides are equal, just like a square.
Equal.
See,
Yeah.
in a square, all sides are equal. In a rhombus, also all sides are equal. Then what's the difference?
But in a square, it forms 90 degree, but in a rhombus, it doesn't.
All the angles of a square, form 90 degrees. But in the rhombus, that's not the case. Okay. So let's see what the question is saying. The diagonals measure how much, Hiba?
16 centimeter and 30 centimeter.
Okay. 16 centimeter and 30 centimeters. Okay. Wait, I have not drawn this properly. Just give me a minute. I think what I should do is this. All right. Hiba, what did we discuss last time about the diagonals of a rhombus? Do you remember?
No.
The diagonals of a rhombus intersect each other at 90 degrees. Or in other words, diagonals of a rhombus, any rhombus, are perpendicular to each other. Okay?
Okay.
All right. Just give me a sec, Hiba. And not just perpendicular to each other.
Can you tell me how they're perpendicular to each other?
Okay. See, the thing is, whenever if you form a proper rhombus, okay, make the diagonals. Okay, so do one thing. Let me show you the image of any rhombus. One sec, let me search. A rhombus. Just a minute, let me share my screen. Yeah. Can you see this? Can you see this figure? So what will happen when you see, number one, see, the condition is that all the sides have to be equal. And the thing is, when you measure the angle over here between the diagonals, it will always come out to be 90 degrees. And as for why is it 90? Why is it a right angle? For that there is a proof of it. Okay, a mathematical proof that you will study later on. You will study that in your 9th and 10th grade. Okay.
Okay.
If you want to find out how do we know, or One way of knowing how it is perpendicular, how the diagonals are perpendicular, is that you draw any rhombus, given that, or the condition is that it should be a proper rhombus. What is a proper rhombus? There's nothing as a proper rhombus. It's just, when I'm saying proper, that means that you don't just randomly draw a shape that looks like a rhombus and you call it a rhombus. No, draw a rhombus by measuring each of the sides properly, so that each of the sides should be equal, accurately equal to each other. Okay, then you will find that the diagonals are perpendicular to each other. Are you understanding what I'm saying?
Yeah.
Yeah. So when you measure them using a protractor, they will be perpendicular. And as for how does that happen, for that, you will study it later on in your 9th and 10th grade. So let me come back to the whiteboard. Yeah. So let me remove these extra signs. I will just make it confusing. So number one thing is that they are perpendicular to each other. The second point is that they bisect each other. What does bisect mean?
What does bisect mean?
Okay. Hiba, let me give you a hint. You've heard of the word intersect, right? Two lines are intersecting each other.
Yeah.
The word bisect has come from this only. Bisect.
So like they don't intersect.
They do intersect. But bisect means they divide each other in equal halves. For example, let's say that you have this purple line over here. Okay. It is falling onto a blue line segment in such a way that it is bisecting the blue line segment. What does that mean? That the blue line segment, these two parts are equal. For example, Hiba, what happens is, let's say if you want to cut an apple, okay? You want to cut an apple. You want to cut it into two equal halves. What will you do? You will cut it right in the middle, right?
Yeah.
So what you have done now is you have bisected the apple.
But how are they intersecting?
How are they what?
Intersecting.
Can you see that they are intersecting? What is the meaning of intersecting?
Like two lines cross each other.
Yeah. Intersecting means crossing each other. Right now we are talking about the two diagonals, okay? Intersecting means crossing each other. Bisecting means crossing each other dividing in such a way that both, the parts that are formed, this part is going to be equal to this part. All right. And this part is going to be equal to this part. That is the meaning of bisect. And again, your question might be, how is that happening? How do we know that it's bisecting? Well, you can always measure it. You can measure it using a scale and you will find that it is always equal. Okay, what is always equal? This part will be equal to this part. And similarly, this part will be equal to this part. The length, it will be equal. Okay. Hiba, are you understanding that?
Yeah.
Okay. So, Hiba, please note it down. Diagonals of a rhombus are perpendicular bisectors.
Yeah, I wrote it down, but can you give me like the definition of bisect so that I can mark it down?
Bisect means divide into two equal halves. Hiba, what does bi mean?
Like dividing.
See, bi means whenever you use this this prefix bi, it means it has something to do with the number 2. For example, there are some people who are bilingual. What does that mean? Lingual means language. Bi means two. So people who are bilingual, what does that mean? Those people know two languages.
Okay.
Okay. Similarly, there are people who are trilingual, just like we have triangle, right? So trilingual means tri means three. Okay, and lingual means languages. So trilingual person knows three languages. Okay, bilingual person knows two languages. Similarly, there are things like binoculars. Have you ever seen binoculars?
No.
Have you ever heard of binoculars?
No.
No. Okay, fine. Then let's not talk about binoculars. Have you ever ridden a bicycle?
Yeah.
Okay, bicycle means a cycle which has two tires.
Two tires.
Similarly, there's something called a monocycle. Have you seen that ever in like pictures or something?
Yeah, I think.
Yeah. Similarly, there's a tricycle which small children use that has three wheels. Okay, so bicycle means two wheels. Okay, bicycle means two. So now are you understanding why we say bisect?
Yeah.
Good. So bisect means intersect in such a way that it divides it into two equal halves. Sect, by the way, sect means part. It comes from the word section. Okay?
Okay.
All right. Anyway, so let's come back on track. What have we learned? That diagonals of a rhombus, this is only about rhombus, okay? Diagonals of a rhombus, number one, they are perpendicular to each other. That means they form a 90-degree over here. Number two, they bisect
How are
each
they
other.
forming a 90-degree?
Hiba, see, I haven't made the diagram like, very accurately because I have not used a scale. But if you make a rhombus by yourself, then draw the diagonals and then measure the angle. You will see that it's 90 degrees.
How do we measure the rhombus?
How do we measure the angle?
Yeah.
Okay. Heba, you have a protractor?
Yeah.
You know how to use a protractor?
Yeah.
We even used an online protractor in the 5th chapter, lines and angles. Remember?
Yeah.
Yeah. So that is how you will measure this angle. What you will do is you have your protractor, take your protractor. It looks like this, right? It looks like a semicircle.
Oh, okay, I understand now.
Yeah. Keep the center part of the protractor over here and then measure the angle.
Okay, I understand.
Okay. So, all right, Heba, till here it's understood. They are perpendicular to each other and they bisect each other.
Yeah.
Okay. Now, so each of these, how many triangles do you see here? How many small triangles do you see?
4.
4. 1, 2, 3, 4. Okay. So these are 4 small triangles. In fact, there are bigger triangles also, but we don't need those for our this question. For example, this triangle. Similarly, this one. Okay. So we don't need these triangles. Right now we only need these small 4 triangles. Okay. Can you tell me one thing about these 4 triangles?
They are.
What type of triangles are they?
Isosceles.
Okay. Let's look at, for example, let's look at this one. Just a minute, bacha. Look at this triangle, okay? Only look at this triangle. Don't look at anything else. Now tell me, what kind of a triangle is it?
Equilateral.
It's an equilateral triangle. Are all the 3 sides equal?
No.
Then how is it equilateral?
A right angle triangle?
Yes, it is a right angled triangle because there is a 90 degrees angle over here. Okay. Is it an isosceles triangle, Hiba?
No.
No, very good. All right. So, can you read the question again? What does the question say about the lengths of these two diagonals?
16 centimeter and 30 centimeter.
Okay. So now just look at this red diagonal. Okay, this one. They are saying that this one is 16 centimeters. So if the whole thing is 16 centimeters, then what will half of it be?
30.
Sorry?
30.
Bacha, see, listen to
Can
the
you
question
explain
again.
again?
What?
Can you explain again?
Yeah, I'm repeating the question. They are saying that there are two diagonals, okay? One diagonal is 16 centimeters, let's say the red one, and the other diagonal is 30 centimeters. Fine?
Yeah. So,
So
the
what
half
is
of 16 will be 8 and half of 30 will be, am I right?
30 will be?
15.
15. Very good. So Hiba, in this triangle, can you tell me, in this yellow triangle, can you tell me what will be the sides of this triangle?
16,
16.
30 and x.
One sec. Bacha, what is 16? This whole thing is 16.
Which whole thing?
The red one. Can you see the one that I've just drawn? This whole thing is 16. The entire diagonal is 16. Then this entire diagonal is 30.
Okay.
So that's what I'm asking you, that if this entire thing is 16, this whole one, then what is half of it?
8.
8. So can you tell me what are the lengths of the two sides of this yellow triangle?
It will be 8 and 15 and x.
Very good. Which one will be x, by the way?
The yellow one.
Very good. So this is 8. This one from here to here. Yes?
Yeah.
From here to here is 15. I'm sorry, I didn't write the unit. It's important to write the units. 8 centimeters, 15 centimeters, and this one is x. From here to here, we can call it x. Okay.
Okay.
Now, in this right angle triangle, can we find x?
Yeah.
Yeah. Do it. How will we do it?
Okay. Okay, wait. It will be 8. Wait, it's confusing. Like,
okay, wait. Don't look at anything else. Oops.
because the
Only
right
look.
angle triangle is in middle of all the numbers, so I can't like tell which. Like I can't use the hypotenuse method. You know.
Hiba, try to tilt the phone in such a way that the triangle starts looking like this. Try to tilt the phone.
I did.
Okay. Now just focus on that yellow triangle. If you're not able to, if you're not able to ignore the rest of the figure, if it's too much on your screen, then you can just hide it using your fingers, hide it using your hand, and focus only on that yellow triangle. And now tell me.
It will be x.
It will be
X.
I'm asking, how will you find x?
Yeah, I mean 8 is to, sorry, not 8 is to 8 square plus
Very
15
good.
square gives x square.
Very good. Then?
So it will be 64 plus for 15 it was 125.
225.
225 and then wait a second. 225. X square gives 289.
Very good. So x squared gives 289. Now, what is x?
16.
16?
No, it is
16 square will end with 6, right? Whatever the answer is, it will end with 6. Yes?
Yeah.
7. Sorry?
Sorry, 17 plus
17.
Multiplied.
X is equal to 17. Because 17 multiplied by 17 gives you 289. So x is equal to 17 what? Centimeters. Okay?
Okay. Can you give me 1 minute to write it down?
Yeah.
Can you explain once again why we have to find the half of 16 and 30?
Okay. Hiba?
Yeah.
What is 16? 16 centimeters is what? What does it denote?
The red one.
The red diagonal. Yes?
Yeah.
But we don't want this, the whole one. We just want from here to here, how much is it? Why do we want that? Because we want to find the sides of this triangle. Okay. How do you know how much from here to here is? Well, you know for a fact that the diagonals of a rhombus, they bisect each other, meaning that this part and this part will be equal, meaning that this entire diagonal is being divided into 2 equal halves.
Okay.
So this red part is going to be half of the whole diagonal.
Okay, I understand.
By the way, Hiba, we have not completed the question. The question doesn't ask us to find x. What is the question asking?
Find the perimeter.
Perimeter. So first you write till here, then we'll discuss about how to find the perimeter.
Okay, I wrote it.
Done? Okay, Hiba, now how will we find the perimeter?
By drawing a rectangle.
No. What is perimeter?
2 multiplied by L plus B.
But that's a perimeter of a rectangle. That is the formula of a perimeter of a rectangle. I'm not asking for formula. I am saying what is perimeter. Perimeter hota kya hai?
Like boundaries, like I think.
Yes, very good. Perimeter is the total length of the boundary. Okay?
Okay.
The total length of the boundary. So what does that mean? That means this side plus this side plus this side plus this side. Now, Hiba, can you tell me one thing? Can you tell me what is the thing special about the sides of a rhombus?
They are equal.
They are equal. So if this side is x, which is 17, then all the sides will be
17.
17. So each side is 17. So what is the perimeter going to be? Perimeter is, let's write it over here. Perimeter is sum. Sum means addition, okay? Sum of all the sides. So what is the sum of all the sides in this particular question?
Like 17, 8, and 15.
Can you repeat, Hiba?
Like 17, 8, and 15.
Hiba, what are we talking about? We are talking about the boundary. We are not talking about what is inside the rhombus. Boundary. Can you tell me what each of these sides is?
Yeah, okay.
From here to here is 17. Okay. Then from here to here
68.
is
68.
Sorry?
68.
You're telling me the perimeter?
No, actually 51. Yeah, I'm telling the perimeter.
How 51?
17 multiplied by 3.
By 3. Why 3? There are 3 sides in a rhombus. You said right. The first time you said right. 17 into 4, which is 68 centimeters.
17.
Okay. Because this is 17 plus 17 plus 17 plus 17. So 17 is 4 times. Did you get it now? How to solve this type of question?
Yeah.
So you have to go step by step. What was the first step, Hiba? What was the first step that we did in our question? The only thing that was given in the question. So in the question, the only thing that was given was the number 1, that it is a rhombus. Number 2, that it is the diagonals, the length of the diagonals was given. Okay. We were asked to find the perimeter. What was the first step that we did?
We found x.
No, before that, before finding x, what did we do? We divided, divided the diagonals by half, right? We found out half of the diagonal. We found out half of the diagonal, right?
Yeah.
That is basically to say the 2 sides of the triangle. Then we used the Pythagoras theorem to find x. And what is x? X is the
217.
Yeah, but x is the side of the rhombus, right? Yes?
Yeah.
Okay. Then from the side of the rhombus, we were able to find the perimeter. Perimeter is equal to sum of all the sides. So we did it in 3 steps. Now is it clear to you, the whole question?
Yeah.
Good. Okay. All right, Hiba. So we will have a test for this chapter, okay? Only for this chapter, we will have a test. Let's have it on Monday. Okay?
Okay.
Will you be able to prepare till then?
I have to study for my exams.
When are your exams starting?
On Thursday. Next Thursday.
Next Thursday. So you have to study for maths also, right?
Yeah.
So you studying for the test is not any different from you studying for your math exam. Or is it different?
Yeah, I will study.
Good. All right.
Oh, by the way, I scored 58 out of 80 on the previous exam.
58 or 68?
58.
58. 5. Okay. So
Yeah.
What do you feel about your marks?
They are good.
Achha. Do you think you could have done any better?
Yeah.
Yeah. So where did you go wrong?
I don't know.
You don't know? Okay.
I think the fractions.
All right. Hiba, do you have your answer sheet with you?
No, but I can ask my teacher.
Yeah, please ask your teacher for the answer sheet. Bring it home. Send me the picture of the entire answer sheet. Okay.
Okay.
Good. Send it to me in a PDF format. If it's in a PDF format, it will be easier for me.
Okay.
When will you send it to me?
After Sunday.
After Sunday. Okay, fine. All right.
Or like on Sunday.
Okay, on Sunday. So, Hiba, one question. Your school gives you a holiday for Friday and Saturday, or only Friday?
Friday and Saturday.
Okay. And Saturday, you are busy, or you have time on
No,
Saturday?
I have some time, then I have to study.
Okay. Now let's come to the 7th chapter, Congruence of Triangles. So, what do you understand
we
from the
didn't
word
find the
congruence?
perimeter.
What?
We didn't find the perimeter.
Didn't? What is 68 centimeters?
Oh, I forgot.
You write it down, okay? Write it down. Then we'll move forward.
But isn't it like 2 multiplied by L plus B?
Hiba, that is the formula for a rectangle. Okay?
There's different parameters of different.
No. They are not different perimeters. See, Hiba, perimeter means sum of all the sides. When it comes to a rectangle, the perimeter, which is, so in a rectangle, this is called the L, the length. Yes?
Yeah.
This is the B, breadth. Again, this side is L and this side is B. When you add all of them, when you add all the sides, sum of all the sides, when you add them, what do you get? You get L plus B plus L plus B, which is nothing but 2 times L plus 2 times B.
2 times B.
Now you take 2 as common and you get 2 times L plus B. So this is the formula that we arrive at. Similarly, for a square, if this side is, let's say, A or S, whatever it is, okay, the perimeter is what? Sum of all the sides. And the thing is, with the square, all the sides are equal. So all the sides are what? A. So it's A plus A plus A plus A. And that gives you 4 times A. Similarly, in a rhombus also. In a rhombus also, all the sides are equal. So if one side is, let's say, A, then all the sides will be A. And then your perimeter will come out to be 4 times A. Getting it?
Understood. Yeah.
Okay. Let me know when you're ready. Done?
No, wait a second.
Okay.
Okay, I'm done.
Okay. So Hiba, what do you understand by congruence? Do you know what the word congruent means? You must have studied it in school. So What do you understand by this?
I wasn't there in this chapter, but I think it means like equal, right?
Very good. In a way, it means equal. Okay. See, Hiba, the thing is, we say two things to be equal when both their numerical values are equal. Okay. For example, this line or this line segment is equal to this line segment. Okay. What does that mean? That if this is 4 centimeters, then this is also 4 centimeters. So in a way, we are saying 4 centimeters is equal to 4 centimeters. They are equal. Okay. But with shapes and like real life things, you don't use the word equal, do you? For example, take a look at both your hands. Okay.
Yeah.
Join your hands together.
Okay.
Yeah. They are superposing each other. This is called superposition. Okay. Superposition. They are covering each other completely. Yes?
Yeah.
They are congruent. Are your hands equal? Are you going to say my hands are equal? You can say they are equal in length. You can say they are equal in breadth, in width. But for something that is a two-dimensional figure, okay, for things that are bigger than, lines, things that are like shapes, you don't say equal. You use this word, which is congruent. As you said, it conveys a meaning of equal only. If two things, you can say two lines are equal, or you can say two lines are congruent. Line segment, sorry. All right. So similarly, let's say your two hands, your two palms are congruent. All right. Similarly, let's say you have two phones, the same model, same brand, like same company, same model, two phones. Okay. Their color could be different. Their, internal settings could be different. But their overall physical appearance, like not the appearance, but the physical shape, the physical size, same model, same brand. Yeah, they are equal, or in mathematical terms, they are
congruent.
When you place them on top of each other, you will say that they're exactly fitting, right?
Yeah.
On the other hand, if you take one phone of one particular model and you take another phone of a different model, then they might not be exactly equal. One might be a little bit wider, or little bit longer, or a little bit thicker, right?
Yeah.
Yeah. So this is an example of two things being congruent. Okay. Okay, now one more thing is that let's say you have two angles. Okay, this is one angle, or okay, this is one triangle. Fine. And or not triangle, let's do it like this. Let's say this is one right angled triangle. All right. And this here is one square. Now look at these two angles. Don't look at the shapes. Just look at these two angles. Is this a right angle?
Yeah.
Is this a right angle?
Yeah.
Are they both congruent?
Yes.
Yes, very good. Angles are congruent. When we say angles are congruent, that means they are equal. Okay. It doesn't matter what is the size of the square or whatever the other things are. The only thing that makes angles congruent is the fact that they should be equal. Okay. So,
but how do we know they are equal?
Okay. Do you know that this is, I just told you, what did I tell you? This is a right angle triangle. So right angle triangle means this angle is
90, 90
degrees. I told you that this is a square. Square means this angle is?
But other than a right angle, what else could be equal?
In these two shapes?
Yeah, or like any angle.
Okay, for any other angle you're asking. You're asking, how do we know if two angles are congruent or if two angles are equal or not, right?
Yeah.
You simply measure them. You measure them, okay? If, let's say, I put an angle over here and I put another angle over here, you don't know the measure of this angle and the measure of this angle. Unless and until you know these two angles, you can't say whether they are congruent or not. Or one thing you can do is that you can cut out this entire thing. You can cut it out and paste it over here and see whether it fits exactly. If it fits, then they are congruent. If not, then they're not. Okay, do you remember that activity that I showed you on Microsoft Paint? That one where we had three angles of a triangle and then I cut out each of those angles and then I placed them on the number line. Remember?
Yeah.
Yeah. So that is an example of cutting out angles and pasting them. Got it?
Yeah.
Okay. Now let's talk about congruence of triangles. Okay. Till here we have talked about what? We have talked about congruence of line segment, congruence of angles. How do we know whether two triangles are congruent or not? For example, let's go back to this rhombus. Okay.
What is the definition of congruence of triangle?
Congruence of triangle means that those two triangles that we are talking about should be if you can superpose them, then they should exactly lie on top of each other. For example, or you can say that those triangles are the exact same in each and every aspect. Okay, that means their sides are equal, their angles are equal. Sorry?
Can you wait for 1 minute?
Okay.
Okay, can you explain again?
Sorry?
Can you explain again?
Which part? How do we explain congruence of triangles?
Yeah, the definition.
Okay. Congruence of triangles means, first of all, you need to understand what does congruence mean. Congruence means
equal.
The two shapes should be equal in every single aspect. Okay. For example, when we were talking about these two phones over here, their breadth should be the same.
Same.
Their length should also be the same. Okay. Their thickness should also be the same. So all of the dimensions, or you can say the angles between them, they should also be the same. Even if one small thing is different, even if, let's say, length is the same, angles are the same, but the breadth is a little bit different, then will you say that they are congruent?
Yeah.
No. If the breadth are different.
Oh, yeah, we can't.
Yeah. Okay. So similarly, even in triangles, we say that two triangles are congruent when every single aspect.
Can you explain the breadth thing again?
Okay. See, what I said was, in order for two shapes to be congruent, every single aspect of those two shapes should be congruent, or should be equal.
Equal.
What does that mean? That over here, let's say we were talking about these phones. So in the phones, the length should be, both their lengths should be the same. Both their breadth should also be the same. All of their angles should also be the same. Even if one thing is different, for example, if the breadth is a little bit different, then will you say that they are congruent?
No.
No. Let's say everything is the same. Length is same, angles are same, but breadth is different. Then they will not be congruent. So similarly, even in triangles, we say that two triangles are congruent when all of their aspects, in all their aspects, they are equal. Okay. Like this side, what does that mean? This side should be equal to this side.
This side.
This side should be equal to this side.
Okay,
this side should be equal to this side. Not just the sides, the angles also. This angle should be equal to this angle. And so on. All of the three angles should be equal to each other. Are you getting it?
Yeah.
Okay. All right. So Hiba, let's ask ourselves this question. What if I have a triangle? In fact, I have two triangles in which all three angles are the same. Let's say, for example, this one, okay? This triangle. This is a triangle. And
right angle triangle.
Yeah, I mean, I have drawn as a right angle triangle, but it could be anything, okay? So there's this one angle and there's another triangle. This is, let's say this is triangle A. I should not be naming it like that. This is A, B, C. Okay. This is triangle ABC. And there's another triangle, which is called triangle PQR. Okay. And I will tell you that in these both triangles, it's like angle A is equal to angle P. Okay. Angle B is equal to angle Q. Angle C is equal to angle R. Okay, what are we saying? That all the angles, all the corresponding angles are equal. Okay. In this, whatever angles of this triangle are the same in this triangle, they are all equal.
But there are no parallel lines. So how are they corresponding?
Okay. See, corresponding means if I'm talking about angle B over here, so Hiba, corresponding means two things. Okay. Number one, corresponding angles. When we are talking about parallel lines, corresponding angles are this angle and this angle, right?
Yeah.
Corresponding also means one more thing, which is if we are talking about two congruent triangles, let's look at these two triangles. Okay. Then let's look at this purple side. This side is corresponding to this side in the other triangle. Okay.
Oh, okay.
The green angle in this triangle is corresponding to the green angle in this triangle. Hiba, just give me a minute. I have to go get the door. Okay.
Okay.
All right. Okay, so now did you understand the meaning of congruent? I'm sorry, corresponding.
Yeah.
Okay, so these are corresponding parts of the two triangles. So we were talking about, yeah. So these three, this angle is equal to this angle, this and this are equal, this and this are equal. Now tell me, does that mean that these two triangles are congruent?
Yes.
Yes? Okay. Let me give you an example. Let me just erase this because I need this space. Okay. Now here, this angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. Are these two triangles congruent?
No.
No. So simply on the basis of their angles, we can't say that the two triangles will be congruent. And by the way, the symbol for congruence is this, equal to sign and this. Okay?
Okay.
So if I say ABC, triangle ABC, and then this symbol, triangle PQR, I will read this as triangle ABC is congruent to triangle PQR. Okay? So over here, are these two triangles? Sorry?
But what if angle ABC and angle PQR are not congruent?
Triangle, bacha, not angle, triangle.
Yes,
They are
triangle.
not congruent. So you will put this symbol, okay? So Hiba,
Okay.
is it clear how just by looking at the angles, even if all of the angles are equal, we can't say that these two triangles will be congruent. Is that clear?
Yeah.
Then what is it that will help us determine whether an angle, sorry, whether two triangles are congruent or not?
Can you repeat the question again?
What are the things that will help us determine whether two triangles are congruent or not?
Their length and breadth.
Breadth? Do triangles have breadths?
No. They will be the
sides?
Sides.
Right? So the sides have to be equal, and even if we, let's say we know a few sides and we know a few angles. Okay, so angles also have to be equal, but just by looking at angles, you can't say. It should be a combination of both of them. Okay.
The sides are more important.
Yes, exactly. Sides are more important.
Okay, I understand.
Very good. All right. So Hiba, if I tell you that there are two congruent triangles, let's say this one and this one. The other one is also going to be look exactly the same as the first one, right? I'm sorry that it doesn't look exactly the same because I'm not using a scale. I'm just drawing rough measurements. I'm just drawing a rough figure. Okay, so these two triangles are congruent to each other. Let's call them A, B, C, and PQR. Okay, triangle ABC and triangle PQR. They are congruent to each other. So now, what are the corresponding parts, Hiba? What are the corresponding parts? You will say, yes.
Angle AP, I think.
The side AB, yes. The side AB corresponds to the side
PQ.
PQ. Please write it down. Let's write.
Can I draw first?
Yeah, sure. If you want a break in between, Hiba, you can tell me. We can have a 5-minute break because today's class is for 2 hours, right? So we can have a 5-minute break. Just let me know whenever you need one.
Okay. Then it will be PUR. Sorry, AC is corresponding to PR.
Very good. Let's
And
do
then
one sec, Hiba. Let me write it. And are you writing it in your notebook?
Yeah.
And are you writing it the way that I have written it over here? AB is corresponding to PQ?
Yeah.
Yeah, write it like that. AC is corresponding to PR. Next.
BC is corresponding to QR.
Very good. The line segment or the side BC is corresponding to the side QR. Now let's talk about the angles. Okay. In fact, before the angles, even before the sides, we should have talked about the vertices. Okay. Now tell me which vertex is corresponding to which vertex? Vertex. This is called the vertex. Vertex A.
And vertex P.
Vertex P. So you have to write it like this, corresponding vertices. Over here, we have written corresponding sides. You have to write corresponding vertices. And then A is corresponding to P.
Okay, wait a second. Corresponding vertices.
Yeah, corresponding vertices. Vertices. It is the plural of vertex.
Okay, wait a second. And then B is corresponding to Q.
Very good.
And then C is corresponding to R.
Very good. So Hiba, you can also see it like this. A is corresponding to P. So if I write it like this, how had we written it? ABC, triangle ABC is congruent to triangle PQR, right? So A is corresponding to P. B
corresponding to Q.
B corresponding to Q. So similarly over here we have B corresponding to Q. Similarly, if C is corresponding to R, then C and R are just, C is right on top of R. Similarly, you can see that over here we had AB corresponding to PQ, the sides, right? So AB is right on top of PQ. And similarly, BC is right on top of QR. So this is one way in identifying how to tell which sides are corresponding to which sides. Because over here the triangles are simple, right?
What about AC and R and
AC.
PR?
Okay. AC, let me show you. Let me first erase this part.
Oh, I understand.
Understood, right? AC is like this. PR is like this.
Yeah, okay, I understand.
Okay. So, Hiba, now the angles. Let's come quickly to the angles.
So now it will be corresponding angles.
Yeah, corresponding angles.
Angle AP.
Angle, this is angle BAC. Or you can just call it angle A.
Okay. So angle AB is corresponding to...
Again, Hiba, the name of an angle will either have 3 letters in it, like angle ABC, or it will have only one letter, which is angle B. Angle ABC means which angle, Hiba? Angle ABC means this angle. That means you're starting from A, you go till B, and then you come till C. Angle ABC. This is angle B. Angle ABC and angle B is the same thing.
Okay, I understand.
Say, continue.
Can you explain again?
Which part exactly?
Like what are the blue things, like blue angles? I didn't understand.
The blue angles?
Yeah.
Which one?
In A, B, and PQ. I didn't understand that.
Okay, see, bacha, AB is the line segment. Okay?
Yeah.
AB is the line segment. It's not an angle, first of all. How do you name an angle? You will say angle A, which is over here. Or another way to name angle A is you will say angle BAC. When you are saying BAC,
but in some questions they only mention two angles.
No. They will never write only two letters. They will either write one letter or they will write three letters. They might say angle A and angle B. What does angle A and angle B mean? This is angle A. This is angle B.
Okay, understood. So angle AB is corresponding to PQ.
Repeat, Hiba, what?
Angle AB is corresponding to
angle AB.
ABC.
Which angle is ABC? Is it the light blue one or the dark blue one?
I don't know, because why are there only two?
There are three angles, Hiba. How many angles are there in a triangle?
Three, but why are there only two?
We have only marked two because we were just matching them, right? We haven't reached this part yet.
Okay.
So, there. I've marked it. Fine. No problem.
Yeah.
See, I've told this to you before also, Hiba. Just because I haven't made this mark over here does not mean that the angle doesn't exist. Okay? Is that okay?
Yeah.
Now tell me, you are talking about angle ABC. Which angle is angle ABC? Can you tell by the name of the color?
Blue, dark blue, and green.
That is the triangle. You were talking about the entire triangle. I am saying angle ABC is one angle. Which angle is angle ABC?
Angle A and angle B and angle C.
No. See, angle A can also be written as angle BAC. Why do we name it like that? Because when you say BAC, your gaze should shift from B to A and then C. So angle BAC means angle A. Where is it forming the corner? It is forming the corner at A. So this is angle A. Angle BAC does not mean the sides. No, it means only this angle. This angle over here, this one. This is angle BAC. Or in other words, you can call it angle A. Is that understood?
Why isn't ABC and BAC?
Why isn't ABC?
No, why is it BAC and not ABC?
And not ABC. Because angle ABC is, give me a minute, angle ABC is this. When you say ABC, you start from A, go to B, then you say C, right? ABC. The corner is being formed at B. So look over here. Angle ABC means angle B, this thing, the corner. This is the corner. That's why we call it. The other way to call it is angle B. But there's a short name and a long name. The long name is angle ABC. Angle ABC is this angle. Angle BAC, on the other hand, is the angle when you start from B, then you go towards A, then you say C. So angle BAC is this one. Understood?
Yeah.
Pakka?
Yeah.
Okay. Now tell me, which angle is angle, can you tell me according to the color, angle ABC or angle BAC? Okay, angle BAC. Now when I say BAC, your eyes should go from B to A to C. Now tell me, angle BAC is which color?
Dark blue, light blue, and then dark green.
Bacha, angle BAC is just one angle.
Yeah.
You are naming all the three angles. Angle BAC is this light blue angle over here. This is angle BAC.
Okay, understood.
Okay.
But I don't
Angle
understand
BAC can also be written as angle A.
I don't understand how it's BAC.
You didn't understand what?
How it's BAC.
Okay, that's what I was telling you. Let's see it again. See about. Why are we saying BAC? Because this is the way of naming. Okay, let's see how to name line segments, right? How do we name line segments? Let's say you have a line segment over here.
Can we have a 5-minute breaks? I want to go pray Maghrib.
Yeah, okay, fine. We can have a 5-minute break. All right, Hiba. Please be back in 5 minutes, okay?
Okay. Angle was B.
Yeah, I know. How is the you are asking about the naming of the angle, right? I know. I'm asking how do you, before we talk about angles, let's talk about a line segment first. How do you name a line segment?
Like the two angles.
Angles? This is a line segment. How do you name it?
The two sides. No, sorry, like the
Points.
lines.
The 2 points, right?
Yeah.
Okay. Now, let's say there's a lot of points on this, okay? Let's say this point is A, this is B, this is C, and this is D. What will you name this entire line segment?
Line segment A, B, C, D.
No.
Line segment A, B,
AD.
and line segment.
No. It is line segment AD. Why do we name? The thing about naming is that why do we name? First of all, you need to know that so that we can identify. So that we can not just about shapes and figures and line segments and angles, but also in real life, why do we name people, or why do we name schools, or why do we name pets? Why? Or places, so that we can identify exactly. Like, for example, if I'm talking about Hiba Irfan, then I know that there is, if I'm talking about, if I say the word Hiba Irfan, and the other person whom I'm talking to should know which person exactly I am talking about. There should be no confusion. This is called identify. Okay, so that you can identify exactly what you're talking about. So Hiba, when we are talking about this particular line segment, the best way to identify it is to just name the starting point and the ending point. If I say line segment AD, you know that I am talking about this entire line segment over here, which starts from A and goes all the way till D. I am talking about this line segment. If I say line segment AB, then you will quickly look at from A then till B. From your gaze will start from A, it will go till B, and only this much. Your line segment AB is only this much, whereas your line segment AD was the entire blue thing. Got it?
Yeah.
Okay.
Wait, can you explain how you got AB again?
AB, when I say AB, you will look from A to B, and whatever is in between that, this is the line segment AB.
Okay, so it's just like AB, not ABCD.
This red line segment, only the red line segment is AB. This is the starting point of AB, of the red line segment, and this is the ending point of the red line segment, which is AB. When we are talking about the blue line segment, AD, this is the starting point of AD, and this is the ending point of AD. And we only talk about these 2 points. We are only going to mention these 2 points, A, D. That's it. In between, there are going to be millions and, in fact, an infinite number of points in between them, right? Are you going to sit and count all of those points? Sit and mention all of those points?
No.
No. So to name something, a line segment, we only mention the starting point and the ending point. Okay?
Okay.
Now, Hiba, can you tell me what will be the name of this green line segment? Let's first see where is it starting, where is it ending?
It will be B angle BD.
Are we talking about an angle, or are we talking about a line segment?
Sorry, line segment BD.
Line segment?
BD.
BD. Very good. It's starting from B, ending till D. That's it. Over. Right? Clear?
Yeah.
Okay. Yeah. Now, the thing about angles is a little bit, it's a one level higher than line segment. Why? Because let's say I have 2 angles over here. This is one angle. Okay. And over here, this is another angle. Then if you say, if you, talk about the angle, what exactly is the angle? This angle over here is this one, right? Let me show you from here till here. And this one is from here till here. Fine.
Yeah.
Now, if we adopt the same technique that we had for line segment, what was the rule for line segment? You mention the starting point, mention the ending point, and that's it. So if we do that, the starting point of this angle is from this point. Let's call it A. Okay, this is point A, this is point B. So if I call it angle AB, is that going to be enough? You're going to ask, ma'am, which angle? There are two angles over here, right?
Yeah.
So that's why an angle has 3 letters in it, or 3 points that we mention in it. Okay. Why is this the case? Let's see what an angle is made of. Number one, an angle is made when two line segments are intersecting with each other, or they are meeting each other, right?
Yeah.
What does that mean? You have one line segment over here and another line segment over here. There you go. You have an angle, right?
Yeah.
Now, to identify an angle, this is the angle that we have. To identify an angle, as we saw, you need how many points? 3 points. 3 points, Hiba. How many points? 3 points. 2 line segments, 3 points. Over here we discussed, right?
Can you show again?
Yeah, see. So how do we name it? We talk about this point. Okay, let's say this is point A, this is point B, and this is point C. Give me a minute, Hiba. Okay. Yeah. Where were we? Yeah, we were talking about this. So Hiba, how we identify the angle or how we name the angle is, see, first you saw that to name a line segment, we need 2 points. The starting point and ending point. To name an angle, you need a starting point, okay, an ending point, and a point in between, which is called the vertex. This is the main part of the triangle, of the angle, okay. See, there are 3 ways of naming an angle. Number one is, you just call it, okay, number one is by naming each of these 3 points, the starting point, the vertex, and the ending point. Just like in the line segment, we had starting point, ending point. We didn't need a middle point or any point in between. We didn't need it. It was not required. But in the case of an angle, it is required, because just remember this example that we had, that if you want to name it, just angle, if you say, ma'am, this is angle AB, then I will ask, which one are you talking about? Is the red angle AB, or is the blue angle AB? Are you understanding?
No.
Okay, which part did you not understand?
The one you just explained right now.
This one, okay. Hiba, tell me this. How will you name this angle? This, let's say, how will you name the red angle?
A and B. Sorry, AB.
AB. Then what about the blue angle?
AB.
So can 2 different angles have the same name?
Yeah.
They can. Then if I say angle AB is a right angle, which angle will you am I referring to here? If I tell you that, Hiba, angle AB is a right angle, then you'll be like, ma'am, which one are you talking about? There are 2 over here.
Yeah.
So again, that's why we were talking about why do we name something so that we can uniquely identify it. Its identification is unique. If I have a triangle, let's say, Hiba, if I have, let me give you a bigger figure over here. Let's say that I have a shape, a quadrilateral over here. And in this, I say this is A, B, C, D. And again, I'm calling this point as A. Does it make sense? Can I say that this point is also A? This name is already given to some other point, right?
Yeah.
So I can't call this point as A. Why? Because every name has to be unique. This point, I have to give it a name which is something new. Let's say I'll give it O or P or whatever. But it should not be the same as any other point. Similarly, so what did we see here? That every name should be unique. One name or one particular point can have only one name, or one name can be there only for one particular point or one particular angle or one particular line segment. Is this clear?
Yeah.
Now tell me, what will you name the red angle over here?
AB.
AB. Then what will you name the blue angle?
AB.
Can two angles have the same name? Again, Hiba. Again, we are repeating the same thing which we discussed here. Can 2 points have the same name?
No.
No. Can 2 angles have the same name?
But they are different angles, right?
They are different angles. So how can they have the same name? Over here, they are 2 different points. This point is different. This point is different. That's why they have different names. Different points have different names. Okay. Similarly, different angles should have what? Same name or different names?
Different.
Different names. You cannot name 2 things as the same name. Is that clear?
Yeah. But
so
there's
now tell me. What?
But there's no any other point. So how would
exactly? That is the problem that we are having when we say that, oh, I have 2 points, so I will just name it using 2 points. No. To name an angle, how many points do you need? You need you need 3 points. You will not be able to name an angle if you have only 2 points. You have to name this point as something, let's say P. This point is something else, let's say Q. Now, can you name the red angle?
APB.
Angle APB, very good. And the blue one is?
AQB. Angle AQB.
AQB. Okay. Now, see, you yourself have named the angles.
So we can just put any like alphabet.
Yeah. If the alphabet is not given to you, if the letter is not given to you, you can name it whatever you want. Now the point is here, Hiba. How did you name it APB? You started from A. The starting point is A. Vertex is B. The ending point is B.
Ending point B.
Okay. Yeah. Similarly, okay, so to avoid any confusion, I will change these names. Okay. These names of these points. Let's call it, this is L. This is M. This is N. How will you name this particular angle over here?
Angle LMN.
Very good. Angle LMN. Because the starting point is
L, the vertex is M, and the ending point is N.
Very good. The middle point, the middle letter over here is the vertex. See, so this is one way of naming the angle. This is one way. The other way of naming an angle is just say angle M. Okay, this is just by when we are mentioning only the vertex. Remember that this second way of naming an angle, it is useful in many situations, but in some situations you cannot name an angle like this. Do you want me to give you examples?
Yeah.
Okay. Let's say you have a triangle over here. And this is a line segment. Okay. This is, let's say, X, Y, Z, and D. I want you to name, let's say, this angle. The pink angle. Okay, one sec. So there's the green angle also, and the combination of both of them, which is the blue angle. If it's too small for you, you can zoom it in and see. Now, Hiba, if I say angle Y, you will ask, ma'am, which one is angle Y? There are at the point Y, at the vertex Y, you have three angles. Angle DYZ. This is also an angle which has vertex Y. Yes?
Yeah.
Angle XYD. This is also an angle which has vertex Y. And angle XYZ. This is also an angle which has vertex Y. So now the question arises, you will be like, ma'am, you're talking about angle Y, but which one? Over here, there are so many angles. So that's why when you have a situation like this, you use this particular method of naming angles. The first one. This is more accurate. It helps you understand. Is it clear?
Yeah. So like in X, Y, D, and Z, for that one, we can just name it angle Y.
No, we cannot name it angle Y. We will have to call it, we'll have to be specific. Which one are you talking about? Because if you say angle Y, then there will be confusion. Which one are you referring to exactly? So you have to be specific. If you're talking about the pink angle, you have to say angle. Can you name it?
Which angle?
The pink one. Can you see the pink one?
Yeah. DYZ.
Very good. See, now you know how to name angles. So it's angle DYZ, the pink one. The green one?
XYD.
Very good. And the bigger one, the blue one?
XYZ.
Very good. So you got it. And by the way, the third way of naming an angle is sometimes we write it like
yes? When do we use like angle M?
Okay. When do we use the second method?
Yeah.
When you don't have a situation like this. For example, over here you can't use, see, because you have at the vertex B, you have more than one angle. So if you have a simple plain triangle A, B, C, you can say this is angle A, this is angle B, this is angle C. You can use that method over here. But if you have a line segment going from here, or let's say a line segment going from here, then you won't be able to use, you can't say angle C. You can say angle A, angle B, and whatever this angle is, and the full name.
Why do we have to specify the names?
Sorry?
Why do we have to say angle A and not angle A, B, C?
Okay. See, Hiba, angle A is this one. Okay. You can call it angle BAC if you want. You can use the long form whenever you want. But I am saying that the short form can only be used in situations where it's not, confusing. Got it?
Okay.
Okay.
But where can we use the second method? It's still confusing.
In situations like this, angle A, triangle ABC, you can say angle A, this is angle A. Okay? Angle B, this is angle B.
But why do we have to specify them?
What do you mean? Why do we have to specify them?
Like angle A, angle B, and angle C. Why can't we just write angle ABC?
You can. I'm not saying that in this case, you have to use this method. I'm not saying that. Your question was, Where can we use this type of naming? So I'm telling you, we can use this type of naming in this kind of situation. Sorry?
So there are three methods and we can use any
of them wherever it is suitable. Okay.
Okay.
The third method was you can just write over here, like for example, if you write over here 1. So this becomes angle 1. Remember we used to use this in the lines and angles chapter?
Yeah, I know.
Okay.
Yeah.
Now coming to this again. So Hiba, the light blue angle, what is the name of the light blue angle?
A light blue?
Yeah, this one.
Angle A.
Yeah, very good. Can you tell me the full form of that angle? Like just now you learned how to name angles, right? Using
angle
3 letters.
Angle BAC.
Very good. Excellent. Okay, so I'm really glad that any other doubts in this?
No. But no? How can we name the second triangle?
Sorry, which one?
The second triangle. PQR.
In triangle PQR, you were talking about the triangle PQR?
Yes.
Okay, what do you want to name over here?
QPR.
Yes, very good. So angle BAC is corresponding to angle QPR. Is that right? Yes?
Yes, it is correct.
Okay. All right. So all right. Now let's take a look at one more, or before looking at the example, let's quickly complete exercise 7.1. Okay, because at least one exercise you should complete today, right?
Actually, in this chapter, they omitted so many questions. So can I just look which questions they omitted?
Hiba, can you repeat?
In this chapter, they omitted so many questions in each exercise. So can I just take a look at what questions they omitted?
Yeah. Just tell me.
Okay, I'll be back. In exercise 7.1, the first two exercises, the first two questions are omitted.
Okay, the first two questions are omitted. All right. So question number 3 and 4. Let's come to question number 3. Hiba, can you also tell me for the rest of the okay, for the rest of the exercises, you will tell me as we go ahead, right?
Yeah.
Okay, good. Now let's come to question number 3. Can you read it out?
Yeah. If triangle ABC
is congruent to
triangle FED under the correspondence ABC corresponding to FED, write all the corresponding congruent parts of the triangle.
Yes. What does this mean? Let's draw a triangle over here, ABC, and a triangle over here, FED. Okay. If I write here A, B, C, what should this point be?
ABC.
No, what should I name this point? This is the other triangle. This one is triangle ABC. This one is triangle, the other one FED, and they are both congruent. What should I name this?
F, and then the
F.
second one E,
This one
and
should
the
be
E.
And this one should be
P.
It's D, I think. Yeah, it's D. I'm sorry, I've written it like a P. Okay. You have to write the corresponding parts. So first of all, let's write the corresponding vertices. I think, Hiba, you can do this by yourself.
Yeah, I will try, but
Can you take it as a homework or do you want to do it in class?
We can do it in class.
Okay, you want to do it in class? All right. Corresponding vertices.
First, do we have to find the sides or the vertices?
First, let's start from the vertices.
Okay, wait a second. Correspond. It will be angle.
No, vertices, bache. Vertices.
Triangle.
Vertex means the point.
A is corresponding to F.
Very good.
Yeah, FF.
Hmm.
And then B is corresponding to E.
Very good.
And then C is corresponding to D.
Very good. All right. Then next, corresponding sides. Yeah.
It will be angle.
No.
AB.
Sides, bache. Sides. Not angle.
Side AB is corresponding to side FE. And side BC is corresponding to ED. And then lastly,
you don't have to say side again and again. It's understood. When you say AB, it's understood that it's a side only. It can't be anything else. Then?
And then angle AC.
Side, not angle. Just say AC.
Okay, AC is corresponding to FD.
FD, very good. Then corresponding angles.
Angle BAC is corresponding to EFD.
Angle EFD, very good. Angle, one sec. Hiba, see, so you can use the full form also. You can use the short form also. Okay. So you can, instead of saying angle BAC, you can also say angle A is corresponding to
angle E.
F.
Oh, sorry, F.
Then? Then, Hiba?
Yeah, it is corresponding. So, what do we have to do next?
Bacha, you only said one angle, right? Can we talk about the other two angles?
Angle CAB is corresponding.
Bacha, angle CAB is the same thing as angle BAC. See, angle CAB. CAB. Which angle is it talking about? Angle A. Angle BAC, which angle is it talking about? Again, angle A. Okay?
Okay. So,
you said angle BAC, this one, and angle EFD, this one. Then?
But in the previous thing where it was ABC and PQR, you only said like the corresponding angles will be angle BAC and QPR.
No, Hiba, we were not talking about just one. I'm sorry if that led to any confusion in you. See, in everything, I just wrote one because I wanted you to write the rest of them by yourself.
So what will be the remaining?
The remaining one, tell me what is the name of this angle?
B.
Yes.
Angle ABC.
Very good. And that is corresponding to?
PQR.
Angle PQR. Then what is the green, dark green one?
Angle CAB.
CAB.
No,
What
no,
is the
angle
starting point of that
CB,
angle?
angle CBA.
Angle CBA. Which one is angle CBA? CBA means from C you go to B, then you go to A. So CBA is this one.
Angle ACB.
Very good. You can just say angle C also. That is also totally fine. Okay.
Okay.
Angle C is corresponding to angle R. Okay.
RPQ.
RPQ is this one, the blue one.
RQP.
RQP is this one. Why? Because R is the starting point, Q is the vertex, P is the ending point.
PRQ.
Very good, PRQ. So you can say PRQ or you can say angle R, short form. Okay.
Okay.
All right. Done.
Yeah, I'm going to find the next one. Wait. I
Till now,
think
see, till now we have covered this angle and this angle. Now let's talk about the other two angles.
CBA.
CBA, very good.
CBA is corresponding to angle DEF.
Angle CBA is corresponding to angle DEF. Then so we have talked about this one and this one. Next.
Then angle ABC.
ABC is again this one. A is the starting point, B is the vertex. B is the vertex at which the angle is formed. So we're talking about again this one?
No. Angle CAB.
Angle CAB means vertex is A, middle point.
Oh, angle ACB is corresponding to angle ACB.
Angle
FDE.
FDE, very good. Angle ACB